All right, let's get started. Very excited to have everybody here today to join us for a fraction of what you need to teach with Ryan Dougherty. As many of you know, fractions are one of the most important areas in math for students' success and future success, as well as probably one of the most difficult. I'm sure many of you have students that struggle with fractions. So Ryan is here today to help us with that. So Ryan he was in the elementary math classroom as a teacher for 9 years. He was the math curriculum coordinator for 8 years. So 17 years of being involved in mathematics education, although he still is, because for the last 10 years, he's been in supplemental curriculum sales. And I do have to step back, which I think I left out. When Ryan was the math curriculum coordinator, his emphasis was grades 3 to 5. So that is perfect for our webinar today with Ryan. And with that, Ryan, lights, camera, fractions. I'm going to stop sharing and turn it all over to you.
All righty, thank you. Let me kind of pick up where you left off there and share my screen. I think I got the right one. Now, it's not going to look quite as nice as Mark's. I'm going to try to jump back and forth between a couple things, but I just need both screens open. So we're going to spend a little bit of time on here. Most of the time we're going to be spending that in Brainingcamp. So one of the things I want to share with you first before we get started is I have taken, if you're familiar with Brainingcamp, you know that we use share codes and we use Brainingcamp Live, and we use a couple other tools to kind of communicate with each other and share ideas. I have created this tiny URL. So it's tinyurl.com/fractions And if you go there, you're going to get, I'll click on it. I don't know if it's, it'll pop up. What you'll get is just this here. This is my notes that I use. I've done this presentation for a couple years. Actually, it's the last time I'm doing it because we'll record it and keep it up on Brainingcamp. But these are just my notes and the things that I want to talk about and highlight. But right here, all of those are codes. And those are the codes that we're going to be using today throughout the program. You don't need to worry about it today. I'm going to do this a little bit differently. We're going to use something called Brainingcamp Live. And I'm going to kind of push you along and move you or move you from one problem to the next. And you just need to do one thing in a minute and then come along for the ride and participate as much as you can. So, all right, our agenda today. The first thing I want to do is show you this Brainingcamp Live. You are going to be a student inside of it. I will be the teacher, and you will be able to see my screen and what a student's screen is on your computer. Then we're going to get into the fractions, and we're going to talk about what is a fraction, how to show equivalent fractions, comparing fractions, adding and subtracting, and multiplying and dividing unit fractions by whole numbers. That's where we're going to top out. As Mark said, I was a 3-5 coordinator. So that's kind of the span that I'm thinking about when I created this presentation was students who are in 3rd grade through 5th grade, but I know we have some middle school teachers here that are going to probably have some good ideas on how to help those kids who still struggle with fractions. So first thing is, if you go to Brainingcamp and you sign in, right up here where it says share code, in a few minutes, I'm going to give you a join code for a live session. That's where you're going to enter that. And what's going to happen is your computer and my computer are going to connect. And I'm going to see everybody in the session, everybody who's here with me live today. I'm going to see a copy of your screen on mine, and I'm going to be able to watch you working in real time. If you are doing this on a recording, this is also where you enter the share code so you can go and do these activities on your own, right? All right, so that's going to be the key thing. You don't need to worry about it just yet. I'm going to start with our first problem. What is a fraction? Again, these codes, don't worry about it. I'll take care of those. So the first thing we want to do today is talk about just what is a fraction. Have our kids understand what a fraction is, right? So it says here, look at the large red tile. If I want to break it up into smaller pieces, what color pieces can I use? So I've already gone and made this share code, and I'm going to open it up right now. So as a teacher, I've created this page and I want my kids to work on it. And this is where we're going to start Brainingcamp Live. I come up to share. One of my options is live. This is only on teacher accounts. And when I click on live, it says we're going to start. And here's the code. Now, this is the code that I need you to type in, right? I'm going to copy it and put it in the chat so everybody has it. I'm going to leave it up for another minute while you are signing in. When you come in, I want you to notice it comes in as 01, 02, 03, whatever. That is the number that you have joined the room. So right now I can see as it's flashing, I have 7, 8, 15 people joining. If you wanted to change that, so you're no longer just a number and you wanted to put your initials, you can, as you come in, edit that so you have your initials. Or up here where my join code is, you should have a little pencil and you can click on that and change your letters or numbers or whatever number you want it to be or whatever set of letters you want it to be. All right. So now that you're in, now it looks like I have 30 people participating with me, 34 people have joined. Again, I can see all your screens down here. Right now, I can tell some of you are on computer screens, some of you are on your phones. Phones may be a little tough to do some of the stuff today, but this is going to be a hugely participation active session, right? I'm going to give you problems. I want you working through them, seeing how they can be modeled and seeing how they can be used in your classroom, right? All right. If you get kicked out, if something happens and you want to come back in, up here in the corner of my screen, that is the join code for this live session. So if something happens, we have a lot of people on here. We haven't seen it happen, but if it does, that's how you come back into us. Okay, so first off, I'm going to lock the activity. You should all see your screens lock up so you can't do anything. I want to talk about what is a fraction. This piece, I've gone into my fraction tiles and I have set my tools to be blank. I can set them to anything I want, but I'm setting them to blank. I don't want to worry about numbers right now. I don't want the kids to worry about that stuff. What I want to do is get the kids thinking about breaking things into equal parts. So I would pose this question to them. This is going to be our whole. This red tile is our whole. What color tile would you use to break it up into 4 equal pieces? Now, they should not have much familiarity already with these pieces. You may already have it too, but when I unlock this, I want you to play around and see which piece equally covers that, which piece can you use 4 times to equally cover that red tile? All right, go ahead. And while you're doing that, I'm going to pull up all your screens and watch you guys work in real time. I see number 22. This is great. Number 22 is trying the orange ones. You tried it. Oh, that didn't work. Deleted it, right? Tried a bigger piece or a smaller piece, depending on how many pieces they had, right? Number 5, again, they're trying the green pieces. Oh, they just erased it. That wasn't that. They got 4. They still needed more. So they know that piece isn't going to work. What I'm seeing is most of you are finding that this yellow, oh, look at this one here, that the yellow pieces are working. I love this one. I'm going to load this up on the screen. This student here has tried the green. That's not it. Tried the pink. That's not it. Tried the orange with a green. I love that I can see what they're doing and trying to, figure out what the kids are thinking as they're doing this. So I am going to pull up one person's here. That looks like they got it. I'm going to pull up number 24. I'm going to load that on the screen. Let's look at number 24. This person was able to find that the yellow piece is able to break that into 4 equal pieces. All right, so we're going to continue. I'm going to use mine, close this down a little bit. Here's the teacher screen. I know that it's 4, 1, 2, 3, 4. The yellow one is going to work. Now it says place one tile here. So this is one of those 4 pieces. And this is a conversation I would have with our kids. I know you guys can already know this. What should we call this piece? It is one of the 4 pieces. So we want this, obviously we want them to get to that this is 1/4. It is one of the 4. The other thing we want them to do is start showing how can we write this, right? So I can click on just the tile that I want, just the one tile, and I can change it. So I'm not changing them all. I just want to change just this one. And I want to say that this is 1 out of my 4 pieces, right? And then they can start looking at it as 1 out of 4 or 1/4. I can go back and redo the same activity. I'm going to get rid of my yellow pieces. I'm just going to delete them. Maybe I wanted to say, change my text here to which one covers 6 equal pieces, right? So I can change that real quick. I hit push, and I'm going to select everybody in the room. And just so you know what I'm doing when I hit push, I'm going to overwrite your screens. So when I hit push, all your screens are going to be updated with the new activity. And it's going to hit all 51 of you or however many are in my group. And so your screens have just been updated by me, right? And we can do the same activity with 6 equal pieces or 8 equal pieces or 10 or 12 or whatever I decide I want them to do. I can change that and push it and challenge the kids. The other thing I could do is kind of go the opposite way. How many pieces, how many green pieces would it take to cover this red one? So the green pieces would be 1, 2, 3, 4, 5. So these we can call them, those are fifths, and we could do the same activity. So we can go both ways, starting with the red, how many cover it? Starting with the pieces, how many do I need to cover it? Thinking about that both ways is going to get kids understanding what a fraction is. And the other thing that is very key here is that these are all equal sizes. We don't want them changing colors because obviously I could do something like this. Maybe you want to do this if you're in the upper grades, right? I could say 2 yellows and a pink equal that size, equals that whole piece, but that's not equal pieces. And we want, initially, we want it to be equal pieces because we're talking about fractions in equal pieces. Joe, you're going to see me pushing a bunch of times, so I'll get into that again in a second, okay? Let's actually kind of move over to the next one. The next section, the next thing I want to do, again, you don't need to worry about this code, is talking about equivalent fractions. Here's the code for you if you are watching. I'm just going to copy this. And then in my live session as the teacher, I'm going to hit this load button and enter this code. And any page that I have created, I can then hit open, and on my screen, it changes the page. I've changed the manipulative. I maybe want to get this up just a little bit higher. And so your screens don't look like this because you're still on that last one. I want to set this up before I do it. I'm going to go 1, 2, 3, 4, and then I am going to group that and get rid of all the fill. So now I have these 4 empty spaces. Now, and Jill, she asked, how do I push? I hit the blue button that says push, and I can differentiate if I wanted to, select who gets what, but I'm going to select everybody because I want us all to move on to the next one. And I will push us over to the next task. All right, so here we are finding equivalent fractions. Finding the equivalent fraction. So how many ways can you make 1/2 using other pieces? Now, I've taken this piece, as you saw me do that, and given you the template, what we need to fill, right? So if you could start taking these pieces and dropping them in, now they may do what I just did here, that they clicked on top. Well, I don't want it on top. I want it on the bottom. We have a rotate button. That's straight. Click on the piece I want, rotate it down to where I want it to be, right? So fill these with different same fraction pieces that are going to be equal to 1/2. And while you're doing that, I want to pull up your screens to see how we're doing. All right. One of the other cool things you can do, I'm going to scroll down closer to the bottom because we have some people on the bottom who don't ever get seen here. Something I can do, I can click on the thumbnail here and say, oh, I like what you're doing, and give a little thumbs up. And that person then gets whatever button I click on, a heart emoji, a smiley face, whatever it is, they're going to get a little message from the teacher that says, I like what you're doing, or I like what I'm seeing. Okay. All right, so let's even do this one right here. This number 24. I'm going to take theirs. I'm going to load it onto my screen so I can see what they did. And I can see here that this person is doing exactly what I asked them to do, but they're using different colors. So what I could do is I'll add a little text here and just say, one color, please. One color, please. And then I can, got to remember, this is 24. I can push that just to student number 24. And that's going to update their screen. I could have sent a message to everybody in the class. Remember, use one color. And now you all get that message, right? I could have sent the message directly to that person. Okay. So I'm going to pull up and look at student number 1. I'm going to look at what they did here. Let me give them 1 second. It looks like they're still trying to rotate some pieces in. I want them to be able to do that if they are. I load that up onto the screen, and we can look at what this student did. Right? I don't want to move it around on them. So we can see that we filled in the same pieces. There's no overlaps. They all look the same as they did as the 1/2. We need a little bit of help rotating, putting these in place. They should snap into place too. But if I wanted to start showing students that these are equivalent, I can go into my teacher tools here, and here is a fractional piece that I could put here and say, well, this was 1. I got to click on my numerator, click on my denominator, 1/2, and I can show it here by saying I have 2/4. No, not 24. 2/4. Right? I can then say, okay, this is 1/2. I'm going to copy it. This is 1/2. They also did 4/8. Denominator is 8. And I can do that for all of them. 1/2, 3, 6, 2, 4, excuse me, 2/4, 5, 10, 6, 12. We can do it for every single one of those, and we can start looking at what do they notice about these fractions? What do they notice about the numerators here when you take 1 times 2 gives you 2, 2 times 2 gives you 4, 1 times 4, 2 times 4, right? And we can have them start doing that discovery of, hey, this is how I can rewrite this same fraction in a different way. And I can have larger numbers, but it's going to represent a different piece, right? So having the kids build these fractions, and you can go back and change, let me close that here. I go back and change it to 1/4. I can change it to 2/3. I can build whatever piece I want. And say if I wanted to do 2/3, I could do that. And then I just delete the fill and just say fill that in. And we can start finding, okay, well, 2/3 is equivalent to 4/6, or well, that would be 8/12, right? And I can do other equivalent fractions with these pieces. So just giving them that framework and saying, okay, fill in these spaces, right? All right, I'm going to move on to the next one. But before I do, up here in the corner, my button says exit. You should have one that says, I think it says share. I'm not sure what the student says. But if you wanted to, you could click that and it will give you the option to copy a picture or download a picture. So if you want to save your work, you can at any time hit that download the picture and save it to your computer. I'm going to move on to the next concept because we're got to remember we got to stay on time here. The next concept, kind of going through the grades, is comparing fractions. And what I want to do now, and this one never works. The code works, it's just the link in my presentation never works. So let me get that one. What I want to do now is show you when you are comparing fractions, 3 different ways that we can look at these fractions to compare them. So again, I'm going to open it up to the next one. I'm going to push this out to you. I'm going to select everybody, so we will get the next one. And we're going to let them update. I'll do it one more time just to make sure everyone gets it. Select everyone. If yours isn't updating it, you may want to just refresh. I think what may have happened is they call it a socket, and that may have been disconnected. But if you refresh the screen, that'll reconnect that. All right, so I'm going to lock the activity real fast again because I want you listening to me instead of trying to solve this. So the 3 ways we're going to look at this is changing the numerator to be the same, changing the denominator to be the same, or changing one of the numbers completely different, right? So let's look at this one first, comparing these numerators. So James has run 1/5 of a mile and Nora has run 2/8 of a mile. Who has run the furthest? What I want kids to do is start looking at these fractions as, do the numerators, are they nice numbers, or are the denominators nice numbers? And in this case, 5 and 8, they're not nice. They're just not good numbers. They don't go well together. But 1 and 2 does. So what I want to do is compare these fractions by making the numerators the same. Can you put an equal sign in between the equivalent fractions? Just use the keyboard. Yes, yeah, you can. Just bring up a text button, hit the equal sign, and that'll work. All right, so let's look. I'll unlock it so you can work on this. We're just working on that top one here. If James has run 1/5 of a mile and Nora has run 2/8 of a mile, who's run the furthest? Let's bring out those pieces first. Here's James. Here is Nora. We can use these pieces to just say, hey, look, I can tell you right now, Nora's run further, right? I can compare them, put them side by side. This one's bigger, she's run further. But I want you using that numerator. So we have 2 choices here. I can change this numerator into 2, so it's the same as this one. Or I can change this 2 into a 1, so it's the same as the other fraction. Let's start with the first one. Let's start with changing 1/5 into 2 equal pieces. Think back to the very first activity we did. If I got rid of this, if I got rid of it, made it blank, and said, I want to know what this piece, I need to cut that into 2 equal pieces. The kids can play around, and what they should find, and what you may find, is that tenths will fill in that perfectly. So we can look at, just like we did in the last activity, 1/5 is the same thing as 2/10. And now if I have 2/10 and 2/8, because my numerators are the same, I can compare those numbers easily. Hopefully, the kids are going to start realizing that the smaller the denominator, the bigger the piece. So when I have 2/10 and 2/8, I can tell you that 2/8 is bigger because I have the same number of pieces and 8s are bigger than 10ths. And that's all we need them to do, is just be able to say that, hey, 8s are bigger than 10ths. If I have 2 of each of them, I'm going to have more. So we know that Nora has run the furthest. And just a side note here, you're going to see in all my examples that I use James and Nora. The reason I do that is a personal one to me. My daughter's name is Nora James. So I use her name in all these things, right? If you're using these with your class, feel free to take those names out. They mean, if they don't mean anything to you, take them out, put your kids' names in there, put anybody's names in there. But yeah, when I was making it, it was just easier to say, hey, Nora James, and we'll do it that way. So you'll see that repeated quite a bit. All right, so we're going to move on to the next one here. Now we're going to do that same activity, comparing fractions, but this time we want to look at our denominators. Because again, looking at our numerators, comparing them, so now they're saving money for a field trip. James has saved 1/4, Nora has saved 3/8. If I look at my numerators, 1 and 3, they're not bad. I could do that, but 4ths and 8ths are so much nicer, right? Because I know 2 4s make an 8. So that's what I would do on this. When I looked at the fractions, it would make more sense to do the denominators. But they can do the same thing, 1/4 and 3/8. But now what I want to do is change these to have like denominators or like pieces. I could change 1/4 to be 8ths. And when I do that, 1, 2, I see here that 2/8 and 3/8. And now I have like sizes. Now it just depends on which one I have more of, right? So here I have 2 of them, there I have 3 of them. Obviously 3 is a little bit bigger than 2. So in this case, Nora had more. If I went the other way, this one doesn't work as well, but some kids may look at it this way and say, you know, hey, I could do it this way. I could try to change this one into 4ths. A little harder for them to see because I have 1.5 4ths. But if all we're looking for is which one's bigger, right? They could look at this and say, well, that's the same size. This piece right here is the same size, and Nora has just a little bit more. And then that way they can know that 3/8 is bigger than 1/2 or 1/4. All right. Last thing we're going to do, and we're going to go here to where it says change to the number line. Down here where it says workspace, if you click on that and number line, I have the next problem kind of hidden on that page. I'm going to check yours out here in a second. But in this example, James and Nora are picking apples. James has filled half of his bucket and Nora has filled 2/3 of hers. Who has filled the most? What I did was in my tools, my teacher tools, I pulled out a number line. I pulled out one for James and one for Nora. And then I can click on it and change this. It's not a good spot to show you. I can change this to be whatever I need it to be here. So I have set this first one to be 1/2. And I have set the next one to be 1/3. So I can move those here. And again, visually lining those up, I can see that Nora has picked more apples. But mathematically, we want to share what they're doing. Let me, how about this? I'll tell you guys how to do it. If you click on that number line, like I just did, and move this slider, you will be able to get different fraction pieces. What I need you to do as students is to move this dial, move this slider until you find 2 equal fractional pieces that match 1/2 and 2/3. That makes, I'm probably saying that incorrectly. But let's see how you guys are doing with it. All right, I got a couple of people moving the pieces here. And a couple people haven't got it to move over yet. I'm wondering what's happening with that, how those haven't. I don't want to mess with it just yet in case someone has it, is working. I don't want to push it out to the wrong people, I guess. All right. Abandoned connections, what I was just told. Okay. So let's look at it here. If I take this slider and I'm going to move it into 6th, because 6 is an equivalent, 3/6 is equivalent to 1/2. And then same thing down here. When I slide this over, if I get 6 here, 2/3 is equivalent to 4/6. Where's the number line? The number lines are hidden. Here's your manipulatives. Here's your teacher tools. Every single manipulative has a number line built into it, right? If you're not getting the updates, I think what we need to do is either refresh your screen or exit out and come back in. Here's the join code right here, and that'll join you. And we push to the next one, it'll update everything for you. But all right, getting sidetracked here. We can see here that 3/6 is the same thing. 1, 2, 3. We can take 1/2 and say that is 3/6. And now what I'm doing is I'm comparing my fractions with equivalent pieces, because, well, 2 to 1 worked well, but 3 to 2 in our denominators didn't work as nicely, right? So I could have used my numerators, but in this case, I want to just change both my denominators to be a nicer number, and that's changing it to 6. All right, any questions there? We got to get into the real good stuff. Oh, I only got 20 minutes. Yeah, we definitely got to get moving. Okay. I'm going to jump back here to my presentation. Now we're going to move to adding and subtracting. There's a couple codes here for this one. This very first one, I think this is an extremely important activity to do with your kids. And I'm going to load this up for you. Exit. And push this to the people who are there. Push it to everybody. Everyone who's still connected will get the update. Okay. What we're doing here with decomposing fractions is kids in early elementary, in kindergarten, first and second, they spend a lot of time decomposing numbers, whole numbers. How many different ways can you make 10? How many different ways can you make 20, or these different numbers? And what they want them to do is to be able to use that. They can break apart a number. So if I said 7 plus 5, they could take that 7, but they can take part of the 5 and break it up and say, I need 3 from that 5 to make a 10. And they teach them to make a 10 thing, to make a 10 strategy, right? If they can get to an easier number, it's going to make addition easier. It's the same thing here with fractions. We want our kids to be able to take these fractions and decompose them in different ways. So maybe I want to take this 7/8 and say, okay, well, I want to do 1, 2, 3/8 and 3/8 and, oh, come on, 3/8 and 4/8. We'll do it this way. Doesn't want to grab it for me today. So I could do 3/8 and 4/8, right? I could do this a different way here. I could do 2/8, no, 4/8, 1/8, 1/8, and 1/8. I can find a whole bunch of different ways to do this. And that's what I want you to do right now, is to break these up, put them into different groups that we can look at and say, this is a different way to write 7/8. Will you teach decomposing after comparing? I know I'm a teacher before. I don't think there's any problem with doing it before. It's just kind of the way when I was getting this presentation ready, kind of the way it fell in the standards that I was looking at. But yeah, I think, showing decomposition before so they could break apart, just like I did that one that was the 3, I'm trying to remember what it was, 3/8. They could kind of break that apart and say, well, this is the same piece as that other piece, so it's going to be bigger. All right, let's look at the way some people have done this, maybe. See if we have anybody who's broken it up. All right, let's take a look at this person's. This person has broken this up into 2/8 plus 2/8 plus 2/8 plus 1/8. Or 1/8 plus 1/8 plus 1/8 plus 4/8. 1/8 plus 7/8, right? And we can start looking at all these different combinations. If I wanted to pick up my pen and I could write on it and just kind of show you that, 2/8 plus 2/8 plus 2/8 plus 1/8, I could write that out in a sentence, in an equation, and show them that equals 7/8. What I want them to see, what I want the kids to understand, is that these numbers can be broken apart and used in a better way. And that's going to come where we get to our next next code. And I'm just going to take it off my sheet. It's the next one on there, the 3G one. Close this out. You load up the next share code. Here it is, 3G2A HFQ9. Push this. I'll push to everybody. There we go. Okay. So here we have two different questions. And the first one is very easy. And it was on here because I wanted the kids to see how easy addition of fractions is. If Nora and James are mowing their neighbor's lawn, Nora mowed 3/5 of the lawn. So she had mowed 1, 2, 3/5, and James had mowed 1/5. How much have they mowed together? Well, since these are equal pieces, since these are the same thing, they're fifths, it's easy enough that I just put those together and it's 3 + 1, just like they did in kindergarten when they're taking two numbers and putting them together. If I wanted to put it on a number line, I could do that, change this to fifths. I have Nora did 3/5, James did 1/5, and you can see that we've equaled 4/5. That's great. But where that decomposing really helps is in a question like this. And I'll push this to everybody so you're already on that next question. Nora and James are riding bikes. Nora has ridden 6/8 of a mile. So we could put out 1, 2, 3, 4, 5, 6. And James has ridden 5/8. 1, 2, 3, 4, 5. If I wanted to take this 6/8 and put that on my number line, maybe change it to eighths. There we go, eighths. How many more would I need to get to a whole? Right? The kids can look at this and say, okay, well, I only need 2 more to get to a whole. So instead of adding all of them, I'm going to decompose that second number and take these 2/8 and put that here. And I can see now that I have 1 whole and 3/8 left over. So instead of having to do all the math and all the different stuff, I could just simply say, I could take a few from this person's and add it here, right? Let me go back and do that again, just the opposite way. I started here by taking Nora riding 6/8. What if I took James? And I take James's distance first. How many more would I need to take from Nora? I could break this 6/8 into 3/8. Again, I get to that whole. I only needed 3 of her 8s to get to a whole. And then I have 3/8 left over. And I can think about that by saying, I'm just going to break hers apart and make a nice, easy number, like making a 10. And to me, this is a whole lot easier for kids to see that if I added 2 more to get to 8/8 or 3 more to get to 8/8, depending on which one, and then I would have some left over, that would be a lot easier than doing the way I was taught, which was saying 6/8 plus 5/8 equals, well, 6 + 8 is 11. This is 11/8. Well, that's an improper fraction because I was told that was an improper fraction, but now their fraction is greater than 1. So these need to be rewritten. And then how many times does 8 go into 11? That's 1 time. There's 3 left over, and these were 8s. That is a lot of work, a lot of steps, a lot of things to remember. And I do remember when I was a kid, that made no sense to me. I could figure it out. I could follow the steps, but it didn't make sense. And by decomposing, when I first started seeing the decomposing of fraction, that's when it all started making sense. Like, oh, I could take a little bit here and make a whole, and this is what I have left over. So definitely one of the better skills is teaching your kids how to do that decomposing. I'm actually going to skip this next one. Just in the sake of time, but if you do get a chance, here are the 3 problems here. Taking a third of a pan of brownies and adding a 1/6, we have unlike numerators and denominators. There's a code for it here. It's all done on our number line. And what I really like about this one is, I do got to show you. I thought we won't solve the problems, but I want to just show it to you. Take it a different way. I'm just going to show it to you here. And the thing that I like about this is if I were to say 1/3 plus 1/6, when I bring this jump out, notice it's in twelfths. The reason it is in twelfths is because on my number line down here, it's in twelfths. If I were to change that, and I'm just going to use this slider to change it to thirds, now when I go and add a piece, it's going to come out as a third. And when I bring it down onto that number line, it will readjust. So if I said 1/3 plus 1/6, I need to readjust my number line to say that I need the next jump to be a sixth. And when I pull that out, it will jump, it'll add to the next spot, right? And you can play around with that. These are really cool because if I wanted this to be, okay, well, I want those to be sixth, right? We want to show kids that you should add like denominators. I can click on this fraction and say that that is going to be 2, change the denominator 6, and it's showing me that that is 2/6, and now I have like denominators. So you can play around with these. There's 3 problems here. You can play around with all of those. If you have any questions about them, you have my email. You can send it to me. We're getting down to the wire here, so I want to show the last ones here. All right. Multiplying fractions. That's the next one we're on. Okay. We really need kids to understand that multiplying is multiplying. Doesn't matter using fractions, doesn't matter using whole numbers, doesn't matter using decimals. Whatever you are doing, multiplying is the same concept. So here, if I said 4 times 5 is the same thing as 5 plus 5 plus 5 plus 5. You have 4 groups of 5. Multiplying fractions is the same thing. 4 times 1/5 simply means you have 4 groups of 1/5, or 1/5, 1/5, 1/5, 1/5. The other thing, and you can do this kind of in your, on a piece of, side piece of paper, or keep track of it real fast, kind of do this in your head. What's 4 times 4? What's 3 times 4? What's 2 times 4? What's 1 times 4? Those numbers, your answers, get smaller every single time, right? So what's 1/2 times 4? If they continue to get smaller as the first number that I multiply by is getting smaller, what's going to happen to that number as we get below 1? Your number is still going to get smaller, right? And I think this is a misconception that we tell kids at a very early age, is that when you multiply, numbers get bigger. That's true if what you're multiplying is larger than 1. If you're multiplying by 1, the number stays the same. If you're multiplying by a number smaller than 1, your number is going to get smaller. So, all right, let me show you the task here. And we will load that, push this out. I often get, I do get this question all the time, working here at Brainingcamp, is how would I, if you want to take a picture of it, take a picture of it. Like number 1 has a whole bunch of notes on it. That's awesome. Take a picture, because I'm going to push it out. I'm going to update your screen in 5 seconds. 3, 2, 1. Okay. I get questions all the time of how do you show multiplication of fractions using Brainingcamp? I think we have one of the simplest ways to do it. So here, Nora's making bracelets for her friend. They each require 1/6 of a meter to complete. Okay, 1/6. We need 4 of them. So here's how you do it, real simple. Copy, that's 2. Copy is 3. Copy is 4. I have taken 1/6 4 times. I can then take that and put that on my number line. I can change this to 6, put these pieces on here, and I can see that 1/6 times 4 equals 4/6. And that's wonderful. That's nice and easy. But you can see in my notes too, I said, well, what if it was 3/5? What if this fraction here was, or it requires 3/5 of a meter, right? It really is the same thing. I take that number and I say, okay, I have 3/5, and I need 4 sets of that. I take that and I copy it. That's 2 sets, just to speed things up. That's 4 sets. Now I have 4 sets of 3/5. If I wanted to, again, on the number line, change it to fifths. I'm going to need to stretch this out a little bit. So I can stretch that out and then go and put these pieces on here. So that's 3, 6, 9, 12. And we can see that we have 12/5, right? If I wanted to pick up my pen and show them that 3/5 times 4, maybe we want to show it 4/1 equals 12/5, right? And then we have a discussion of taking it from the concrete model here that I've just shown you to an abstract model here, like how to do it with the numbers, because we obviously don't want them doing that every single time that they're doing this, right? The other thing too is this will help them when we get to that 12/5 again, and we want to go from a fraction greater than 1 into a mixed number. Okay, well, that's 1 whole, that's 2 wholes. So now I have 2 and 2/5. So a really nice, easy way for them to see that. All right. One more, multiplying fractions, and this is where it gets a little bit trickier, because now it's great when we're multiplying fractions by fractions by whole numbers. Super easy. But it's when it becomes fractions by fractions that it becomes a little more challenging. So here's the problem. We'll push this out to everyone. Nice and easy problem to see. All right, so everyone has this. In our classroom, half the students pack their lunch. 1/5 of those students pack the chocolate milk to drink. How much of the class packs chocolate milk? Okay. I want you to think back to the very first activity we did. So in our classroom, half the students pack their lunch. Let's get rid of that. Oh, no, I'm in Cuisinart, so that's fine. We'll keep that on there. Half of my kids pack their lunch. Well, what piece would be half of this orange piece? And they can play around with it, but what they should be able to see is that 2 yellow pieces equal that. So this is half. This is 1/2 of my kids. I want to get rid of this one. 1/2 of my students pack their lunch. 1/5 of those students pack chocolate milk. So now I need to take this piece and break it into how many equal pieces? It needs to be broken into 5 equal pieces. So now I have to play around here and say, okay, well, what piece can I fit in here? And we might be able to see it here. 1, 2, 3, 4, 5. You know, it's going to be tenths, right? So this is my 1/2 times 1/5. And this is why it's getting smaller, because I'm taking this 1/2 of the whole and finding 1/5 of that. And we can look at this and then have the kids see this is why our number becomes 1/10. If we wanted to take it to the numbers that we say 1/2 times 1/5, they can realize, they'll be able to see that as you multiply across the top is 1 by the denominator is 10. And, they'll be able to see how they got that abstractly. But building that conceptual understanding of what we're actually doing, we need to show them that, hey, we're taking 1/5 of this half. All right, so if you want to get a picture of that, of the work you did there, you can. We're going to try one more before we get to division. Oh, we're cutting it close. Okay, one more before we get to division, because this one blew my mind the first time I saw it. Push it out to you so you have it. Remember to do that. I love it. Whoever number 1 is, thank you so much. I love what you're doing here. I'll show you. They're going to probably put some notes on there on this one too. So James went to the candy store and bought 3/4 of a pound of candy. If 2/3 of the candy was filled with peanut butter, how many pounds were filled with peanut butter? So same thing. I'm back in my fraction tile, so I'm going to get rid of my numbers. This is how much he bought. He bought 3/4. So of this piece right here, 2/3 of it was filled with peanut butter. we could break it up, break each piece into thirds. So let's take each one of these, and what number would I need to, let's actually turn these back on, because by now we should be able to start looking and think about numbers, right? So what would I need? What piece would fit in here 3 times if I broke each one of those up? And we can know that it's going to be 12ths, right? So I can take 2 here, 2 there, and 2 there, and we could show them that, let's put all these back together, that 2/3 of 3/4 is going to be 6/12, and we can continue that and reduce the fraction to make it easier. What blew my mind was when I first saw this problem, or a problem similar to the same numbers, somebody said, hey, you're doing all this work over here. I don't need to do that, because you're asking me to take this piece right here, which already is broken into 3 pieces, and take 2 of them. So I can do 3/4 times 2/3 very easily. I just say, this is the piece that I need right here, this 2/4. And I remember seeing that and being like, oh my gosh, that is so much easier than trying to multiply that out and get 6/12 and then do all the reducing of the fractions, because they had such a good understanding of fractions to know that if they wanted 2 out of the 3 pieces, that's it. That's the piece right there. So that was cool. All right, last one, and definitely one of the harder ones, is division. Same thing I did before. We want the kids to see that 12 divided by 3 equals 4. How many groups of 3 can you get from 12? Or if you broke 12 into 3 equal groups. 4 divided by 1/4. How many groups of 1/4 can you get? Or how many groups of 1/4 can you get from 4? Break 4 into equal pieces. Try that same thing that I did with the multiplication. If I said 12 divided by 4, your answer is 3. 12 divided by 3, your answer is 4. It gets a little bit bigger. 12 divided by 2 is 6. It gets a little bit bigger. 12 divided by 1 is 12, right? So as we do dividing, our numbers become smaller. But when we get into that 1, it's equal again. And now when we see 12 divided by 1/2, we now get 24. So we should be showing the kids that 1 is kind of that tipping point. And then that's where our when you divide, our number gets smaller thing is not always right. All right. So the last one, this is the one that gives people a lot of tricks. We'll load it up. We'll send it out to you. Push. Everybody. Push. All right. So I'm in South Carolina. This is absolutely spot on for them. If James has 3 cups of sugar and he uses a 1/2 cup of sugar to make a glass of sweet tea, how many glasses of tea can he make? I am taking 3 and dividing by 1/2, which is less than 1. So my answer is going to be greater than what I started with, right? Because I know I'm dividing by a number less than 1. I can just pull my pieces out and say, that's 1 cup of tea, 2 cups of tea, 3, 4, 5, 6. I'm taking that 3, and how many equal pieces of 1/2 can I get, or do I need, right? And that's going to be 6. So I'm going to pick up my pen and do 6. Now, all I did was flip the problem around. I did that intentionally, and we'll talk about that in a second, but I flipped that problem around, and now I have 1/2 divided by 3. Again, think about that. I'm dividing a small piece by a number greater than 1. So my answer is going to be bigger than the 1/2, right? So 1/2 divided by 3. No, I'm sorry. It's going to be smaller because I'm divided by 1. So this time it is going to be smaller. Same thing we did that very, very first activity when we're trying to show kids what a fraction is. 1/2, what piece would I need to use to make 3 equal pieces? I would need to use 6, right? 6 make that into 3 equal pieces. So I take that 1/2 divided into 3 equal pieces. I get 1/6, one of them. And my answer here is 1/6. I absolutely recommend when you're doing this, do the same problem, just change the numbers. And it's going to be 6 divided by 1/3, and then 1/3 divided by 6. 4 divided by 1/2, 1/2 divided by 4. Keep these numbers and keep doing the inverse of them. Because what kids are going to start seeing is that in this case, the answer is 6. In this case, it's 1/6. If your answer is 7, the opposite way is going to be 1/7. If the answer is 10, the opposite is going to be 1/10. And same here. If you get 1/4, if you flip the problem around, it'll be 4. The reason I want them to see that is then we can start talking about, well, what happens when you divide by a number smaller than 1? You get a bigger number than what you started with. Or if you divide by a number greater than 1, you get a smaller number than what you started with. All right. We are at time. I've actually gone over just a little bit. I'm going to exit out of that live session and end it, but your session is still open. If you want to play around with that, you can. Go back to our PowerPoint here. And I think I send it back to Mark at this point.